Hello everyone. So we're dealing with polynomials in this video, and the question says that consider the polynomial p of x equals to 2x squared minus 12x plus 12. Which of the following statement is true? So generally, when we're dealing with polynomials, if there is a way in which you can simplify your polynomial, that should be the first step to do. And we see clearly from our polynomial p of x that we can simply simplify this by dividing all through by 2. So if we simplify p of x divided by 2, we're going to have x squared minus 6x plus 10. This is going to make your work to be very easy if you don't simplify. Now we have simplified our polynomial and we have that. The second one says that okay, what you need to consider is which of the following statements are true. It says that the roots of the polynomial are 3 plus I and 3 minus I. So we see that the options are kind of like showing us that there are complex roots. So to consider complex roots, or to check if the roots of this polynomial exist, you need to consider the discriminant. Now the discriminant is given as b squared minus 4ac, and there are properties associated to the discriminant, and those properties are: if the discriminant is greater than or equal to 0, here we have equal and real root and real root and real root. If we have the discriminant is equal to 0, we have equal roots. We have equal roots. Equal roots. If the discriminant is less than 0, then we have complex roots. Complex roots. Now, how can we verify? Generally, a polynomial is usually given as p of x equals to ax squared plus bx plus c. This is a simple example, meaning that our a is in this case 1, and our b is in this case negative 6, and our c is 10. So applying that here, we're going to have b, which is 6, and which is minus 6, and minus 6 squared is 16, minus 4 into a is 1 and c is 10. So we're going to have 16 minus 40. So clearly this value is less than 0. If it is less than 0, according to our properties here, therefore it contains complex roots. Once you have this in mind, you know that our polynomial is going to have complex roots. So here we are going to be looking for those complex roots. Now, how can you get the complex roots? To get this complex roots, you can use any of the methods of solving a quadratic equation. You can use the formula method. You can even use the graphical method. You can use completing squares, which is generally what I will go for, even though it's the most complicated. Using the completing square method, we have our polynomial p of x to be equal to x squared minus 6x plus 10. Now the completing square method simply says that we add half the equation of x and subtract half the equation of x and find the perfect square in our expression. So to do that, we're going to have x squared minus 6x plus half the equation of x. The equation of x in this case is minus 6, so half of that, all that squared. Then we subtract that again, minus 6, all that squared plus 10. So we have that. Now what do we notice? We notice that we have our polynomial here. We're going to consider this, the negative part of it. So we're going to consider this one, this, right? To consider this, we're going to have x minus, right? Because generally we consider the negative value, the negative, since here is negative, right? Therefore we have to consider the one that will give us the negative. So this will be minus 3, all that squared, right? Now minus, remember we have minus 3, all that square will be 9 plus 10. So this is our completing square expression. So to complete that, we are going to have all that squared. This will be plus 1, and if we are solving for the solutions, you equate that to 0. So x minus 3 will be plus or minus the square root of minus 1, which is simply I. So x minus 3 should be equals to plus or minus I, and x now should be plus or minus I plus 3. So meaning that we can have our first value to be 3 plus I, and x2 should be 3 minus I. This is a definition. Now let's look at the options that we have. The first one says the root of the polynomials are 3 plus I and 3 minus I, which I think is correct from what we have just done. So meaning that option A is correct. Now option B, the roots of the polynomial P are 3 plus I and 3 plus I. This is wrong. Option C says the root of P are 2 plus I and 1 minus 2I, which is wrong. Option D says the root of P are 1 plus 3I and 1 minus 3I. That is not what we have. It is wrong. Option E says P of x does not have any possible complex roots. Wrong. Already the discriminant says that it is less than 0, therefore there exists complex roots. And F says P of x is greater than 0 for all x belonging to the set of R. Now, when it says P of x is greater than 0 for all x belonging to R, I think this is correct. If you think about it, our function is always positive, no matter the value, no matter the value that we choose. And from our completing square here, no matter the value of x, this is always going to be positive. So this is always a positive value, because no matter the value, as long as it is in the range of R, if we insert it here and we take square and we add 1, it's always going to be positive. So option F is correct. So option F is correct. So that's it for this video. Please support my efforts by subscribing, and see you in the next one.